Hi everybody, this is the question. In fact, this is the first question that was posted in MIT Integration B 2023 Finals contest. It was a face-off between Mr. Luke and Maxim Lee. Both the gentlemen performed really well, and the success of the tournament was largely attributed towards, or I should say, their performance was the highlight for the success of this particular tournament. So I would like to discuss here the first question posed to these gentlemen, and the question is as follows. They are expected to integrate integral 0 to pi over 2 tan, in fact it is third root of tan x divided by cos x positive sin x raised to the power of 2 times dx. This is 2. This is a very challenging integral, and I am going to show you how this is done. Of course, some of you or many of you all would have known this, but let us see how this question is solved. So foremost, what I wish to do is I would like to let third root of tan x be equal to u. So this can be rewritten as tan raised to the power of 1 over 3 x is equal to u. Right? So if you were to take cube on both sides, cubing both sides, what would we get? This is going to be tan raised to the power of 1 over 3x. This is raised to the power of 3. This is going to be u cubed. So this in turn is going to be tan x is equal to u cubed. Now you can either take it as u or t, whatever you wish to take it as. And if I were to differentiate both sides, differentiating with respect to x, we get. So differentiation of tan x is going to be secant squared x dx, and differentiation of u cubed is going to be 3 times u squared times du. I can rewrite this as dx is equal to 3 times u squared du divided by secant squared x. Now I am not changing the limits at all for the time being. So this is rewritten as integral. Let me just hold the limits for the time being. Now third root of tan x is taken to be as u, and in place of dx I have got 3 times u squared du over secant squared x, and cos x positive sin x. Now if I were to take cos x out, that would become cos squared x of 1 positive sin x divided by cos x raised to the power of 2. Now this is 1 over cos squared x, which can be rewritten as secant squared x. So this and this can be cancelled, giving me u times 3 times u squared du over 1 positive. Now tan x, I should say sin x over cos x is tan x, right? And what have we got for tan x? Tan x is nothing but u cubed. So I can substitute u cubed there and raise it to the power of 2. So this is what I've got. Now let me place the limits. When I'm going to place the limits over here, when x is equal to 0, lower limit is 0, right? X is equal to 0, what happens to u? This is going to be 0, right? So this means u is equal to 0. So the lower limit is 0. Now when x is equal to pi over 2, what happens to tan x? Tan pi over 2 is going to be sin pi over 2 divided by cos pi over 2, which will lead us to infinity, right? So you got a limit from 0 to infinity, and we are expected to integrate this. Now what I wish to do, I would like to apply UV technique, integration by parts, UV method. Of course we got a u here, you got a u here, but since I've taken the entire substitution with u, I don't want to alter it now. So by UV method, what do we know? We know that integral u dv is equal to uv minus integral v du, right? This is a formula that we have studied. So I would like to take the substitution as follows. Let my u be, let me just take this as capital U, right? So this, all of these are capital U, just to have some significance or some differentiation. So u is equal to capital U, and my dv, I'm going to take my dv to be the entire quantity. dv is 3 times u squared du divided by 1 positive u cubed raised to the power of 2. Now clearly du is going to be, when I differentiate, this is going to be du, and if I were to integrate, I need to perform this integration. So what I wish to do, I would like to take 1 positive u cubed is equal to some t. I'm not going to have any limits there. Of course, we know this limit is 0 to infinity, but I'm not going to take any limits as of now. Let me just simplify this. So this is going to be equal to this. If I were to differentiate this, this is going to be 3 times u squared times du is equal to dt. This is what I've got. So if I were to substitute 3 times u squared du, this is going to be dt divided by, in place of 1 positive u cubed is going to be t raised to the power of 2. This can be rewritten as t raised to the power of negative 2 dt. If I were to integrate this, t raised to the power of negative 2 positive 1 divided by negative 2 positive 1, which is nothing but t raised to the power of negative 1 divided by negative 1, which is nothing but 1 over t with a negative sign, which is nothing but negative 1 over, in place of t, I have to substitute 1 positive u cubed, right? So if I were to take the values and place them here, this is going to be equal to u, my u is this capital U, which is the variable which we have been using here, so there is no issue with that. My v is going to be this quantity, negative divided by 1 positive u cubed. Now I can place the limits. The limits are 0 to infinity, negative integral, my v is obtained here, so it's going to be negative of 1 over 1 positive u cubed. That's going to be positive, so 1 positive u cubed is here. My du is nothing but du, right? So this is what we have got. Now the limits are 0 to infinity. Now if I were to substitute the limit here, upper limit minus lower limit, this will cancel, it will become 0. Now all that I've got is 0 to infinity du divided by 1 positive u cubed. So I need to solve this. Now I can write 1 positive u cubed to be as 1 positive u times u squared negative u positive 1, right? I can actually split 1 positive u cubed like this. So this is equal to integral du divided by 1 positive u times u squared negative u positive 1. I'm going to integrate it by partial fractions. So this is going to be a over 1 positive u positive, this is going to be b u positive c divided by u squared negative u positive 1. You cross multiply. In fact, what I could have done is, I could have actually represented the quantity as 1 over 1 positive u times u squared minus u. So let me just write it. So this entire thing is equal to 1 over 1 positive u times u squared negative u positive 1. So first what I will do is I will find out the value of a, b, c, and then I will bring the quantity. This is actually the integrand, right? The integrand without du. So if I were to, or if once I get the value of a, b, and c, I can substitute in place of this, I can substitute this, and then I can perform the integration. So that's the basic idea. So if I were to cross multiply this, I would get 1 is equal to a times of u squared negative u positive 1 positive b times u positive c times 1 positive u is equal to 1. This is what I've got. Now what I wish to do is I would like to take u is equal to 0. If I were to let if I were to take u to be equal to 0, this one will vanish, this one will vanish, so I will have a c here, and then this will vanish, and I will have a which is equal to 1. So that's for u is equal to 0. Now next, let u be equal to negative 1. This entire thing will vanish. If I were to take negative 1, I would get, let me write that down, a of 1 positive 1, because u is negative 1, followed by a positive 1. So that's going to be 3 times a is equal to 1. Therefore my a value is 1 over 3. Right. So I already have a value for a is equal to 1 over 3. If I were to substitute here, I get 1 is equal to 1 over 3 positive c. Therefore c is equal to 1 negative 1 over 3, which is going to be 3 negative 1. That's going to be 2 over 3. So my c value is 2 over 3 and my a value is 1 over 3, and now I need to get the value for b. So I can simply substitute any value. So let me just take u to be as 1. So let u be equal to 1. If I were to take u is equal to 1, this is negative 1 positive 1, that's going to be just a there, a of 1, and this is going to be b positive c, and u is 1, 1 positive 1 is going to be 2. I know the value for c. C is 2 over 3 positive b, and a value is 1 over 3. So this is 1 over 3, and I got a 2 there is equal to 1. So if I were to distribute the 2, I would get 1 over 3 positive 2 times b positive 4 over 3 is equal to 1. Now if I were to take the LCM, if I were to add this and this is going to be 1 over 3 added with 4 over 3. So let me just, if I were to take the LCM, this is going to give me 1 added with 4 positive 2b. That's going to be 5 over 3 positive 2b is equal to 1. I move this 5 over 3 to the other side. I get 1 negative 5 over 3 is equal to 2b. So this is going to be 3 negative 5 over 3. That's going to be negative 2 over 3 is equal to 2b. Therefore b is equal to 2 gets cancelled, negative 1 over 3. So I got the value for b, I got the value for a, I got the value for c. I need to substitute them. So let me flip over to the next page. So hence a over 1 positive u positive b u positive c over u squared negative u positive 1 is equal to a is 1 over 3. So I can substitute 1 over 3 divided by 1 positive u, and b is negative 1 over 3 positive c is 2 over 3 divided by u squared negative u positive 1. So if I were to take negative, of course there is a u there, I need to place the u there. Now what I wish to do is, therefore we need to get the integration, right? So therefore integral, I need to substitute this value. So it's going to be 1 over 3 times du divided by 1 positive u, and this is going to be negative 1 over 3 integral, there is a u there, so let me place that u. If I were to take negative 1 over 3, this is going to be u, so this will also, there is also a 1 over 3 here, right? So if I were to do, or in other words, if I were to take that, I would have negative 1 over 3 times u, that gives me negative 1 over 3 times u, with 2 over, there's a 2 over 3 there, so I need to have a negative 2 there divided by u squared negative u positive 1, there's a du there. So this is what I've got. Now what I wish to do is, I would want to make sure that I have this dx over x form. So for that, it's easy for me to integrate, right? If I were to differentiate this, d of u squared negative u positive 1, I get 2 times u negative 1. So my intention is to have 2 there, right? And if I were to have a 2 there, I need to have a 2 down here. That is multiplying by 2 and dividing by 2. So let me just do that. So this is going to be 1 over 3. I have to multiply by 1 over 2. And then to actually neutralize, I will have to have a 2 here. So in fact, my idea is to have a 2 in the numerator, right? 2u minus 1. I need to have that. So if I were to do that, this is going to be 2 of u negative 2 divided by u squared negative u positive 1 times du. So clearly this 2 and this 2 gets neutralized. So we're not doing any harm here. So this is equal to 1 over 3. I'm not going to replace that using log. Let me just simplify this first. We have yet to get the simplification. So this is going to be 1 over. Now, as I mentioned to you, I would like to have 2u minus 1. So let me take that down. 1 over 3 times 2. Okay, I will write that down like that. So if I were to write this as 2u minus 1 divided by u squared minus u plus 1 times du. So this is easily integratable, right? So let me just place the parenthesis here. But this is actually minus 4, right? 2 times negative 2 will give you minus 4, but I only taken minus 1. So I need to account for the next minus 3. So I need to place negative 3 there, right? And with the integral sign followed by du over u squared negative u positive 1 with a parenthesis. Okay, that looks fine. Now this is equal to 1 over 3 integral du over 1 positive u. Now integral of this is going to be ln modulus of 1 positive u, and this is going to be 1 over 6. Now if you, as I mentioned to you, the derivative is found here, so this is going to be ln of modulus of u squared negative u positive 1 followed by negative. Now what is this? I'm going to rewrite this as integral du over, this is going to be u negative 1 over 2 raised to the power of 2. Now let me just expand this and show you what happens here. This is going to be u squared negative 2 times u, this is producing me u, positive 1 over 4 is here. Now I need to get a 1 there, so that is possible if I were to have root of 3 divided by 2 raised to the power of 2. This is going to give me 3, this is going to give me 4, and these two can be added to produce 1. Fair enough, right? So this is going to be root of 3 divided by 2 raised to the power of 2. Now why am I doing this? Because I know a formula, integral dx over x squared positive a squared is equal to 1 over a tan inverse of x over a, right? This is the formula that I would be utilizing. That's what I'm aiming at. Now I'm not substituting the limits. The limits are actually, for u, it is stretching from 0 to infinity, right? So if I were to draw a big parenthesis, the limits are actually stretching from 0 to infinity, and there is no change of variable there. So the limits are going to stay the same, 0 to infinity. Now let me just simplify this first. So this is equal to 1 over 3 times ln of modulus of 1 positive u negative 1 over 6 of ln of modulus of u squared negative u positive 1, and followed by negative 3 times. If I were to apply the formula, that's going to be 1 over a, right? So my 1 over a is going to be 1 over root of 3 divided by 2, 1 over a tan inverse of u negative 1 over 2 divided by a. That's going to be root of 3 over 2. Right? Tan inverse of x over a. So we need to do some simplification. Now what I wish to do is I would like to bring this 1 over 6 inside. So let me distribute that. So this is going to be 1 over 3 times ln modulus of 1 positive u negative 1 over 6 times ln of u squared negative u positive 1. Now negative times negative will become positive. Now if I were to flip this, this is going to be 2 times 3. That's going to be 6. So 6 and 6 gets cancelled. So that would leave us with 1 over root 3 tan inverse of u negative 1 over 2 tan inverse of x over a. So it's going to be root 3 over 2. So this is what I've got. Now all of this thing have to be applied with the limits. So I'm going to distribute the limits inside. So this is going to be 1 over 3 ln of 1 positive u, the limits 0 to infinity, negative 1 over 6 ln of modulus of u squared negative u positive 1. The limits are 0 to infinity, and this is going to be positive 1 over root 3 tan inverse of u negative 1 over 2 divided by root 3 over 2. The limits are 0 to infinity. This will go, this will go, this would be left. So 1 over root 3. I apply the upper limit. That would give me tan inverse is x over a, right? Tan inverse of x over a. So let me write it like that, tan inverse of x over a. So when I apply the upper limit, I would get here tan inverse of infinity, right? And followed by applying the lower limit. If I were to apply the lower limit, this is going to be tan inverse of 0, negative 1 over 2. I got a root 3 over 2. I flip it. I get 2 over root 3. This is what I get. 2 and 2 can be cancelled. This is equal to 1 over root 3. Now tan inverse of infinity. What is that? That's pi over 2 followed by negative of tan inverse of negative 1 over root 3. That's nothing but negative pi over 6. Now this is equal to 1 over root 3 pi over 2 negative negative positive pi over 6, which is nothing but 1 over root 3. Take the LCM as 6. This is going to be 3 pi positive pi, which is nothing but 4 pi over root of 3 times 6. Now 2 divides here 2 times, 2 divides here 3 times, which is nothing but 2 pi over 3 times root 3. Now we can't have root 3 in the denominator, so I multiply a root 3 in the numerator and divide by a root 3. So this is going to be 2 times root 3 times pi. Root 3 into root 3 is 3. 3 times 3 is 9. And this is the solution for this particular question. And you can clearly see I have expressed every step in detail so that a better understanding can be achieved in solving this question. Thank you everybody. Enjoy your night.